Now we'll talk about section 13, that is ventilation and temperature. Now under this section there are three subsections. The first one says that effective and suitable provision shall be made for securing and maintaining in every workroom adequate ventilation by circulation of fresh air. So this subsection talks about ventilation of the factory. What in case, suppose say there are many people working in a factory and there are machines which are generating heat and there is no ventilation. What will happen? There is no fresh air coming in, so the condition will be like very uncomfortable to work. Okay, so because of which a ventilation is required, and this section says that effective and suitable provision shall be made for having a good proper ventilation. So I'll suggest some of the ways in which we can have a good ventilation inside a factory. The first one is a natural ventilation, in which there are many openings as shown in this image. There are many openings, maybe in the form of windows. Okay, on the rooftops there are openings, so that the fresh air, as shown in the blue arrows, it enters the factory. The heated air present on the shop floor, because of the less density, it will move on top. Okay, and it will come out via rooftops as shown in this brown arrow, and a fresh air will replace continuously the air which moves out. So this is how the process works. This is natural ventilation. Other ventilation type could be a wind driven turbo ventilator. Now this ventilator are basically placed on the rooftops of the building. So what happens is, because of heated air, because of its low density, it will move on top to this roof. From rooftops, because of the pressure difference from the surrounding and the present inside the factory, okay, it will try to come out of this. Okay, the air present inside the factory will try to come out of this ventilator. So while coming out, it will try to rotate this turbine. Plus there will be outside wind which will be flowing, that will also add up to this, and this turbine will start rotating. So what will happen in this process, the air which is present below these rooftops inside the factory will be directed from inside the factory to the surrounding, so which will be then replaced by a fresh air. So this process will continue. So this could be one method. The next method could be providing an exhaust fan. Now this is a artificial ventilation process in which air is forced to move out. Okay, similarly you can have a fan which can force the air to move in the factory, so you can have better ventilation. So these are the various ways in which you can have a good ventilation. So with this we will move on to next clause, which says that temperature to be in reasonable condition of comfort. Walls and roof shall be of such material and so designed that temperature shall be kept as low as possible. Similar to ventilation, temperature also plays a major role in maintaining a comfortable atmosphere inside the work environment. So what if the temperature goes high? It will be very uncomfortable for us to work in the environment. So this clause talks about the material of the factory with which it is made, the walls, the roofs. It says that walls on roof should be of such material that it does not entrap more heat. Now I'll tell you some of the material which could be adding to more heat and some material which will be not. Now material which can cause more heat in a factory premises could be asbestos sheet if placed, or a concrete. Now this has the tendency to entrap the heat and maintain it, whereas if you have a tile bricks made up of soil, okay, or you have a good quality plastic placed on the rooftops, now this material will not entrap much of a heat. Okay, so this could be material which will be very good, but current scenario is that most of the factories used metal sheets. Now this metal sheet, if they are placed at a certain height, good height, then they does not contribute to much heat, and they are also economical, so most of the companies prefer this sheet. And if these sheet are fitted with this wind driven turbo ventilator, then it could be of good ventilation to the factory. So the next subclause is, when the process produces excessive high temperature, adequate practical measures shall be taken to protect the workers. Okay, now suppose say there are certain processes, maybe a melting of some metal, okay, or some processes which requires a lot of heat. Now you cannot have humans standing there continuously. Since the process produces more heat, it will be really affecting their health. So what could be provisions could be made? Now all these hot parts could be insulated as shown over here. Now insulating material can be anything. It could be a glass wool, it could be asbestos, okay, aluminized material which does not radiate heat, which does not allow the material to radiate heat. Now all this material if placed, the first thing which will happen is that contact with the hot parts will not cause much of a damage, plus there will be radiant heat present that will be protected from coming out of these hot parts, so it will not add much to a temperature in the surrounding. Similarly, this separate the hot processes from the workroom. All these hot processes present, okay, so this could be separated from the workroom so that there is less of a human intervention with these processes. So this could be one of the thing. So this is all about the first subsection of ventilation and temperature. With this we will move on to our next subsection. Now we'll learn about the next subsection, subsection 2, which says that state government may prescribe standards of adequate ventilation and reasonable temperature. Proper measuring instrument in such place and such record may be prescribed. Now in this subsection, power has been given to the state government to form standards of adequate ventilation and temperature, and also to mention the instrument required for the same. Now in this, what you can see, yellow color text is the summary of Goa Factory Rules 1985. Now similar rules will be there for the rest of the state, or the most of the state. May not be all the state, but most of the state. So we'll go through this summary. The first rule says that maximum wearable temperature of air in a workroom at a height of 1.5 meter above the floor level shall not exceed 30 degrees centigrade. So if you are measuring at a height of 1.5 meter above the floor level, the temperature shall not exceed 30 degrees centigrade. Now there is term used over here, that is wearable temperature. Now what is this wearable temperature? To know what is wearable temperature, the first we need to know what is hygrometer. The hygrometer is this instrument what I have shown over here. Now this instrument is used to measure relative humidity. Now why this relative humidity required? What's its use? So I'll explain what is relative humidity first. Relative humidity tells us how much water vapor is in the air compared to how much it could hold at that temperature. Now to put this in simpler words, relative humidity is affecting the work. Okay, I'll explain this. Suppose say there are two places, place A and place B. Place A has 90% relative humidity and place B has say 40%. Okay, now what is this 90% and 40%? As the definition goes, relative humidity tells us how much water vapor is in the air. So this is air. Air will contain water vapor. Okay, air is a mixture of different gases, so it also has water vapor. So this blue color is a water vapor. So relative humidity says that how much of this water vapor it can hold, okay, compared to how much maximum it can hold at that particular temperature. So now place A has got 90% humidity, which means that the air is already holding 90% of the water vapor, and place B, the air is already holding 40% of the water vapor. So at place A there is only 10% scope for water vapor, whereas in place B there is 40% scope for more water vapor could be added. So say there are two persons working, at place A one person and at place B one person, and both of them work for around say 2 hours and both of them sweat. Okay, they both have sweat. So what will happen at place A? Okay. The person working at place A will feel relatively hotter. Why? Because after he sweats, since the air already has water vapor, since the air already has water vapor, it will not take water vapor from his body. So the water or sweat which is present on his body will not evaporate. It will evaporate at a much slower rate. Whereas if you consider the case B, since air only has 40% water vapor and there is 60% scope, so water present or the sweat present on the body of this person will evaporate very fast. So once the evaporation takes place, this person will feel very cool compared to that of place B. And one thing to tell you, both are at same temperature, say 30 degrees centigrade. It's not a temperature is different, temperature is same, but just because the relative humidity is different, the person at place B is feeling much cooler compared to that of place A. So this is how relative humidity affects. So relative humidity in the coastal region is usually very high compared to that of dry regions. So working at the coastal regions is comparative is going to feel you much hotter compared to that of dry regions. So this is the importance of relative humidity. So we'll learn now how to use a hygrometer. Okay, so now you know what is wet bulb temperature of air, okay, and how to measure it. So we'll move on to the next. Next is adequate air movement of 30 meter per minute. Now this term talks about ventilation. Now if there is air movement has to happen in a workplace, the flow rate should be 30 meter per minute. Okay, so per minute 30 meter of air should flow. Now for natural ventilation, the opening shall be 50% of the floor area. Okay, in case of a natural ventilation, there should be opening in the form of windows or any opening on the top. It should be at least 50% of the floor so that the fresh air can come. But in case of mechanical ventilation, fresh air supplied should be 6 times the cubic capacity of workroom in an hour. What this means? This just means that in case you have mechanical ventilation, there should be 6 air changes. Okay, the air in a room should change 6 times in an hour. Okay, so 6 times the fresh air should come. That is what it means. Okay, so we'll move on to next. The wet bulb temperature shall not exceed the dry bulb temperature as in schedule. So there is a schedule which is given in the rules. So the wet bulb temperature corresponding to the dry bulb temperature is mentioned, and the wet bulb temperature should not exceed the dry bulb temperature. Okay, but there is one more thing that is mentioned. If the globe thermometer temperature exceeds the dry bulb temperature, then temperature of globe thermometer to be taken instead of dry bulb thermometer. Okay, so in case the globe bulb, now what is global thermometer? Globe thermometer is as shown over here. It is a thermometer which is put in a case, put in a globe which is of 15 centimeter diameter, and it is coated with matte black color. So this is globe thermometer. Now globe thermometer is used to measure the radiant heat. Now what is radiant heat? Now as we have already learned that there are 3 modes of transfer of heat: convection, conduction and radiation. So this is used to measure radiation mode. Now radiation is basically what we get from the sun. Sunlight is radiation. If we burn something, then the heat that we feel is because of radiation. Okay, if anything is hot, it will radiate heat. So this thermometer measures that radiant heat, and if this temperature is more than the dry bulb temperature, then the globe bulb thermometer reading is taken. Now this requirement shall not apply to certain factories when nature of working involves high temperature. Now there are certain factories such as maybe a melting is taking place of iron ore or any non-ferrous metal. Now such factories are bound to have a high temperature. Okay, so such factories are exempted, but provided the worker working in that high temperature zone should not work for more than 1 hour, or they should work for less than that. And after working for less than that, they should be moved on to an area where there is thermal environment is much better. okay, so that they feel cool. They should not be continuously exposed to that high temperature, okay, for more than 1 hour. Now the next is that inspector may serve manager order to provide hygrometer, globe thermometer and maintain such record. Okay, inspector has got the power to tell a manager that they have to make provision for hygrometer or thermometer or maintain such record, or they can also tell to maintain a desert cooler in case. So this is depend if the temperature requires, if the inspector feels that the factory requires it, then he may order such manager to make such arrangement. Now this requirement shall not apply to workroom where the temperature and humidity is controlled by refrigeration. Now suppose there are certain industries such as pharma industries or process industries in which it is required that the ambient condition has to be very low, the temperature has to be low and the humidity has to be depending upon their product. So such companies, this ventilation and temperature will not apply because they already have a very nice ambient inside condition of temperature and humidity, that they did not follow all these rules. In this section we'll be learning about hygrometer. Hygrometer is an instrument used to measure relative humidity. The relative humidity is the ratio of amount of water in the air at a given temperature to the maximum amount of water that can hold at that temperature. Hygrometer consists of two similar mercury thermometers as shown in the above figure. One thermometer bulb is covered by a muslin bag which can be used to keep the bulb slightly wet. This thermometer is called as wet bulb thermometer and another one is called as dry bulb thermometer. The two thermometers are mounted to a wooden board. Assume both thermometers show 30 degrees centigrade. Then the muslin bag is dipped in a beaker of water. Wait for 5 to 10 minutes. Evaporation water from the muslin bag decreases the temperature level in the wet bulb thermometer. So the temperature reading in the wet bulb thermometer will be lower than the dry bulb thermometer. Assume the temperature shown in the dry bulb and wet bulb thermometer are 30 degrees Celsius and 25 degrees Celsius respectively. Note the temperature in both the thermometer. Find the temperature difference between the two readings. To measure relative humidity, take a relative humidity table. This is a table which is used to measure relative humidity. And note the difference between the two temperatures in the column on the top. The point where the row and column intersect is the relative humidity value, that is 65. So the temperature in the dry bulb is 30 degree and difference is 5. So the relative humidity is 65. In this case, the relative humidity value is found to be 65%. Now we will move on to the last subsection 3, which says that Chief Inspector can serve an occupier order in writing specifying the measures to be adopted to reduce excessive high temperature before specified date. Now in a factory, if there is excessive high temperature and Chief Inspector finds that it could be reduced by adoption of certain measures, then he can put that up in writing to the occupier of the factory to adopt these measures and before the specified date. Now we'll learn about section 14, which is dust and fumes. Now under this section there are two subsections. Section 1 says that if any manufacturing process gives off any dust or fumes or other impurity of such a nature and extent as is likely to be injurious or offensive to the workers employed, effective measures should be taken to prevent its inhalation and accumulation in any workroom. So there are certain processes which might generate dust or fumes which could be affecting the health of the worker employed when this fumes or dust is inhaled. So there should be effective measures should be taken or arrangement should be made so that this dust and fumes are extracted. Now in this picture we can see a person who is working on here, and there is fumes which are generated. Now this extractor, what it does is like it extracts all these fumes so that there is no inhalation from this worker. So this is placed as close to the generation point of the dust of fumes so that maximum dust or fumes will be extracted out. So here you can see in this picture that when we were working and there are extracted placed close to them so that all fumes are extracted. Okay, so we'll move on to the next subsection, which says that no stationary IC engine should be operated in a factory unless exhaust is conducted into the open air. Now a stationary IC engine, when it is said, it could be a DG set or any IC engine which may be used to generate pump or any other machinery. Now IC engine has an exhaust which gives out fumes. Okay, so these fumes should not be left inside the factory. A proper arrangement should be made so that exhaust is taken out of the factory and there is no accumulation of this dust of fumes. Similarly, no IC engine to be operated in a workroom unless effective arrangement. Okay, now no IC engine. Now the IC engine could be stationary IC engine or mobile IC engine. Now DG side is a stationary IC engine, whereas a forklift running on internal combustion engine is a mobile IC engine. Similarly, vehicles are the mobile IC engine. So what it is said over here is that no IC engine, that it be stationary or movable IC engine, is to be operated in a workroom. So you cannot operate any IC engine in a workroom unless you make a effective arrangement for taking the fumes out. So via ventilation or force extraction arrangement should be made that there is no accumulation of dust or fumes. So this was all about dust and fumes, section 14.